All right, hello, food chemistry class. I hope you're having a good time, not too good of a time without me. So this lecture is going to cover flavor, all things flavor. And so we're just going to give kind of a brief overview of what the nature of flavor is and then some of the common flavor molecules you run into. So the nature of flavor is really a combination of sensations, from taste buds to odor receptors. So a combination of how you smell the food and taste the food works together, which is why when you have a cold, you can't tell exactly what you're eating. So you only have 6 tastes that your body can really identify, right? Salty, sweet, umami, bitter, sour. And so in combination, you really have to have these odors. And the combination of odor and taste is really what makes a food flavorful. And so it's really important to talk about these aroma molecules, because those are the things that there is, thousands of aroma molecules, and they do all kinds of different things to your senses. And they're small enough and light enough to travel by air. All right, so they're going to travel by air. So these are the things that you smell when you're cooking food. You're really smelling these aroma molecules. All right, so the taste buds are able to do things like salty and bitter, sour and sweet, and then umami, which is the kind of combination of all the other flavors. And so things that are salty sweet would be like putting salt on your watermelon or salt on your caramels. Sweet bitter is really, really dark chocolate that's kind of bitter, but at the same time, the sugar of the chocolate comes through. All right, so what are some of the common molecules that we run into? There's going to be 3 categories of molecules. Now, important fact that aroma molecules, all 3 of these categories are, that looks crazy, are not soluble in water. They are non-polar molecules, and so they do not dissolve in water. And so they're going to be soluble in oil, which is why you have essential oils. Those are aroma molecules that have been stuck in oil. You can't have many other combinations of things. The categories of molecules, the first one I'm going to talk about are terpenes. Terpenes are molecules, let's see, I'll write over here, terpenes. They are of the citrus, mint, and coniferous trees. All right, so here in this figure, I have a few examples of them, but the 3 you need to be able to identify. This guy, which this is limonene. Limonene is the thing that gives flavor to lemons and other lemony fruit. Another terpene that is important, which looks very similar, which is why they all belong to the same family. This is menthol. Right, that's the mint flavor. And then the coniferous tree let's see, I think I want to do, yeah, we'll do this one. Myrcene, which this is the thing that smells like pine trees, pine flavor, it's myrcene. And so all three of these are very similar structures. The difference is this one has double bonds, this one has an alcohol attached to it, and this one, the ring has been opened. But all three of these belong to the family of terpenes. Now terpenes are very reactive and very volatile. So volatile means that they become gaseous easily. Right, so these molecules go from being a liquid to a gas very, very easily, which means they travel to your nose very quickly. And they're very reactive, which means they easily break down. So these will be the flavors that get to your nose first, but at the same time, they don't last very long in cooking, which is why if you're making something and it calls for like a squish of lemon juice, you usually do that at the end, because if you did it at the beginning, it would lose all of its lemony flavor. So we typically just add a little bit of lemon or a little bit of lime at the very end of a recipe so that it maintains a citrusy flavor. All right, the second category of molecules we're going to look at are the phenolics. Oh, here's a cool infographic that includes a lot of the, here's pinene. Pinene is also in the terpene that smells like pine needles. Linalool is lavender. Beta-carotene is black pepper. Myrcene, the one we just did, is pine-y smelling. And then limonene is the one that's from the citrus fruits. So that's interesting. Where you see these flavors other than just cooking. All right, phenolics are another family of flavor molecules. These are distinctive flavors such as, you can see it here, cinnamon, some vanillic flavor, as well as bay leaves and anise are all in this category of phenolic. You can see vanillic acid, very common. These are all compounds, all samples that have some phenolic portions to them. All right, so phenolics will be cinnamon, anise, which is, if you're familiar with black licorice, that's the flavor anise, vanilla, and cloves. These are flavors that we often also associate with fall. And so these molecules look like this. These will be the three. These are the three there in your textbook that I want you to know. Be able to identify. This is eugenol, which is the flavor for cloves. We also have formaldehyde. Which, as the name implies, that's cinnamon. And then we also have vanillin. Which is the flavor of vanilla. So you can see, again, they all have a similar starting shape. They all have this central six-sided molecule with some double bonds. And they all have some combination of oxygen attached to them, either directly or through some double bonds or multiple oxygens. And so cloves, formaldehyde, and vanillin are our three main terpenes, or phenolics. Sorry, these are phenolics. What's different about these is that unlike the terpenes and some of the other aromatic molecules, these are fairly soluble in water. They do dissolve in water okay, which is good for when we're using them in cooking, right? Vanilla, cinnamon, and cloves are all, they give off some of their flavor to the water that you're boiling them or the cake mix that you're adding them to. All right, the last category of molecules we need to talk about is the pungent molecules. And there's two main types of pungents. The first one is thiocyanates, which all have a structure like this. They have a sulfur, and they have a carbon triple bonded to a nitrogen. Thiocyanates are found in mustard, in horseradish, and wasabi. And so when I mean pungent, it means both burns your nose and burns your throat. That these don't have a smell. Like if you opened up a bottle of mustard, they don't necessarily have a smell to them, but when you put them in your mouth, it burns your nasal cavities. And so they act on both your mouth and your nasal cavities at the same time. So that's a pungent molecule. And in fact, it's actually an irritation that causes pain, right? You definitely feel the flavor in your mouth. And so these thiocyanates that are found in mustard, horseradish, and wasabi are, again, they're small, right? They're very small molecules. They're light, they're volatile, and it turns out that they are hydrophobic molecules that end up in the nasal passages and stimulate nerves that respond to pain. So by eating a thiocyanate, you are actually activating your pain receptors. You're telling your body that you are in pain by eating these foods. The other one, this molecule over here, is an alkyl amide. You can see the difference between these, right? This is much longer, it's going to be heavier, and it's not going to be able to travel to the nasal passages like the thiocyanates. These are going to stay in your mouth. And activate mouth pain receptors. So these alkyl amides are found in chilies, ginger, and black pepper. All right, so when we are talking about pain, why do we associate pain and flavor and the irritation of our mouth and nasal cavities with something good? So why is irritating your body so good for taste? Well, the irritation really adds a new dimension of flavor. So this irritation to your mouth, so if you ever injured your arm or your leg or got a bruise, right, that part of your body is very, very sensitive to touching it, right, if you have a big bruise or something like that. You've done the same thing to your mouth. You have irritated your mouth. You have caused it to actually bruised, it's actually inflamed. And it actually makes the mouth more sensitive to new flavors. So these pungent molecules inflame the nasal passages in mouth and make them more sensitive to flavor. And actually, it's not just flavor. It's going to be more sensitive to flavor, temperature, saltiness, and acidity. So if you have some hot food, like some spicy food, in some ways you are enhancing the eating experience because you are going to taste flavors, saltiness, and acidity even more. Now, there's obviously a limit to this. If you choose a strongly pungent molecule, like something over here on the Scoville scale in the millions of Scoville units, past cayenne pepper into habaneros and pepper spray, then you actually are going to desensitize your mouth. So strong pungency, so using very, very, very hot food, diminishes ability to taste. And that could go on for days. Right, when you burn your mouth on something hot, it feels burnt for several days. You've done the same thing. You've inflamed your mouth and nasal passages to the point that they're not going to work correctly. And so it could be several days before you get your regular taste back. So, how do we use this when we talk about cooking with aromatic volatile compounds? So when we are cooking with it, we must find a way to liberate the flavor from these compounds, right? So if I'm thinking cinnamon or vanilla or a pepper, you rarely find it whole in the food. You have to figure out some way to squish the cells that contain the molecule to release it to the rest of the food. So you must break the cells that contain the molecules to release the flavor. All right, so there's a few different ways you can do it. Probably a very common way is to chop, crumble, or grind the vegetable usually. Could be seed. And by doing that, you've broken up the cells and you've made it more available to react with your food. You could also now, I guess these are going to be very dramatic flavor. Like you're going to have a leaf or a seed that you are grinding, crumbling so that it doesn't destroy all the flavor molecules. Because some of the flavor molecules, like the terpenes that we talked about, are so fleeting that by doing this, you actually could disrupt their ability to infuse into your food. So this chopping, crumbling, grinding, crushing actually heat them by doing this physical process. makes them actually more volatile than normal. So our terpenes, they were already fleeting. By doing these things to them, we can't actually keep them from infusing our food like we want them to. So to prevent this, you either use a different method or you just don't chop or crumble them finely. Use them in larger pieces. It's like lemon peel. Instead of crushing up the lemon peel and throwing it in, you usually just throw in the whole piece of peel so it slowly releases the volatile molecules over time. Another thing we could do with cooking is we could use the whole leaf, so like a bay leaf. You use the whole leaf in there, or oregano, or some of these other dried herbs. You use the whole leaf and let them extract slowly. And once the flavor has gotten out of its original molecule, it's then available to react with the food molecule and give its flavor to the food. Let's see what else. Steaming and smoking are great ways to get the flavor out of certain herbs. And that is a slow process. And you actually have the heat of the steam driving the aromatic molecules into the steam, which then lands on the food. So it's a great way of extracting flavor without changing the aromatic molecule. All right, last thing in this chapter is going to be marinades and rubs. And this relates back to our meat chapter that we did last, that marinades and rubs are used on meats. Our aromatic molecules only slightly soluble in water, but very soluble in fat, in oil. And so since meat is 75% water, these aromatic molecules are not going to travel into the center of the meat. They're mostly going to just sit on the outside. So a rub or a marinade is mostly going to sit on the outside with these aromatic molecules sitting on the outside of the meat. Now, like we talked about when we were talking about tenderizing food, when we make this marinade with these aromatic molecules, the liquid that's made in, like if it has salt in it, or if it has some of these other tenderizing enzymes, that's going to tenderize the meat, which breaks up the proteins and allows these aromatic molecules to enter into the meat. And so using a salty or acidic liquid with the aromatic molecules in it allows flavor to infuse better into the meat. So the salty and acidic liquids start to denature the proteins in the meat, which then allow the aromatic molecules to enter into the meat better. And you've probably seen for maximum marination, it's actually not even marinade anymore. What you're doing is you're actually injecting the flavor with a syringe into the meat to bypass the fact that aromatic molecules don't like to travel into the meat by themselves. All right, those are the main points I want to get out of the flavor chapter. We'll do a lab on flavor and flavor testing in about 2-ish weeks. I guess after fall break, we're going to do one about flavors and being able to determine if you have the ability to taste different flavors from each other. I guess that's it. You guys email me if you have any questions, and I will see you next Friday.